Welcome, everyone, to this month's meeting of the Salt Lake City R user group. We are so happy you're here. We will hope to get you all out in an hour or so, so we will kick it off. My name is Julia. I'm one of the organizers, and Andrew, who was just chatting and setting things up, is the other organizer of this R user group. And we are glad you're here. So you probably found us through our meetup page. I'll drop that link here so that you can see our next couple meetings that are scheduled out here for a couple of months. We use the R Consortium's Community Code of Conduct, so I will drop a link to that here. So this is a friendly and professional space, and Andrew and I will be moderating. We're really glad you're here and want it to be a space that is healthy and good for you and everyone else here. We have, yes, we have a couple of meetings that are scheduled out a little bit. And then if you ever want to see our past meetings, they are on our YouTube page. So you can go here. That's the link where you'll see the ones that have been live streamed there. So you can check those out if you want to see any of our past talks. So we have, let's see, we just had an in-person networking gathering, so we will probably set up one of those for August and September again. So if you are from our local Salt Lake City area, we would love to see you in person at any of those about quarterly networking events that we do in person. And then if you are not from the Salt Lake area, we're glad you're here as well. We do most of our talks via Zoom at the Salt Lake City lunch break time. So that's where we are here. We're glad you're here. So today I'm really excited about this topic because I think it's one that really makes a huge difference to how you both experience other people's code and the code you write yourself. And it's, it's not something that I feel like gets taught very early to our users. So I'm really glad for us to be talking here about debugging. So Shannon is our speaker. Shannon, thank you so much for preparing this talk and sharing it with us. So Shannon is a lead data scientist at the Prostate Cancer Clinical Trials Consortium. Shannon has an amazing blog if you want to check that out. And Shannon is also a member of the Our Ladies Global Team, which is a group near and dear to my heart. And Shannon is someone who has really great skills in automating data wrangling and helping people understand what their data is and making new learning material digestible. I know, Shannon, I've seen you teach in workshops at conferences, and I'm really happy for us to have you here sharing today. So let's kick it off. Shannon, are you able to share screen and get us started on learning about debugging?
Do it. Thank you so much for the introduction. I dropped some slides in the chat earlier, and you can hopefully reshare that link to the slides.
I will do that. Yeah.
Most of this is going to be live debugging because you have to see it to believe it, and you have to see it to understand it. But the slides are here for support. Maybe you can go back to for reference, and we'll talk about a couple of key concepts to help organize the thoughts as we go through it. If you have questions at any time, I encourage you to drop them in the chat right away. And hopefully, we can get to those questions right away or save them for the end also. So we're going to talk about some basic troubleshooting steps you might go through before you get into debugging. And then we're going to talk about how you might approach debugging your code, debugging via tools in RStudio, and debugging someone else's code. This work is licensed under Creative Commons, and it actually came out of the two-day RStudio conference, now Posit conference workshop, what they forgot to teach you about R. If you're going to be following along with me, I'm going to assume you have a pretty recent version of R, a pretty recent version of RStudio, and then for the last exercise in particular, you need to be able to build packages. If you want to follow along on your own computer, you can, or you can just watch me. If you're interested in learning more about this topic, there's a whole host of other resources you can check out. And one that I want to emphasize to you is the Jenny Bryan 2020 RStudio conference keynote, Object of Type Closure is Not Subsettable. The example that we'll be going through in this talk is actually straight from her keynote. It's a great keynote. I highly recommend you watch it. All right. So debugging is probably going to happen when you hit some sort of error in your code and you don't really know how to diagnose it. So the first things you're probably going to do is you're probably going to Google that error code. And if you're not familiar with those strategies, I recommend watching this Teach Me How to Google talk by Samantha Fisk. Another strategy you need to use is to reset and restart R. You especially want to do that often and frequently when you're debugging. So we're going to go over what that means in a minute. And another approach you might take when you're debugging is to create a reprex. And my favorite talk on reprex is Make a Reprex Please by Charlotte Gelfand. Whoa, we're not wrapping up. Hold on. All right, so let's talk a little bit more about resetting. When things get weird, you want to turn R off and turn it back on again. And there's a really important setting you need to have enabled in order for this to be most effective. So in order for this to be most effective, you need to have your tools set, your global options, and your workspace. So there's this little thing here, it says workspace. You want to make sure this is unchecked for restore R data into workspace at startup and save workspace into R data on exit to never. So these allow you to properly restart R with a blank slate every time you encounter something weird. And when you're in the debugging process, you're going to be restarting R over and over and over again. And the way you can restart R is through the menu, session restart R, or using your keyboard shortcut. So just as a first exercise, I'll just show you where this is in RStudio, just to make sure you are aware of it. And my Zoom bar always populates over, there we go. All right. So here you're going to go to Tools, Global Options, and then right here, Workspace is the settings I was talking about. If you have any questions about what this means or why we're doing that, I strongly encourage you to put those questions in the chat and we can come back to that. All right, so maybe you've tried those basic troubleshooting tips and you keep getting this error code that you just don't know how to diagnose. And now we're going to talk about strategies you can use to debug code if it's your own code. And things that you might have done in the past to debug your own code is to use print methods, or what I always did myself is I would painstakingly set and interactively run function arguments, but there are really more efficient tools available that you should be using that make debugging such a much more enjoyable and efficient process. So the key debugging concepts we're going to talk about is the traceback. That's identifying the location of where the error occurred. So that's given by the road symbol. We're going to enter the interactive debugger. That helps give you context on why the error occurred. And that's with the little ladybug symbol. And then we're going to talk about strategies that you can use for your own code with a magnifying glass versus someone else's code with a wizard hat. And here is just a large overview of all of the different tools that are out there. So you see some of these tools come in terms of functions, some are in options, some are in the RStudio IDE, some allow you to do some of these things, like maybe some are good for a traceback, some are good for the interactive debugger, some are good for your code, some are good for their code, and some kind of hit the sweet spot in most of these. And it's a lot. This is a lot. There are so many options here when you get into debugging. And I'm going to say that these tools, they really do just about the same thing, slightly differently. And people don't really use all of these tools at one time. So they're going to pick and choose what they like. So that's my goal here, is just to give you an overview of what these tools are so that you can find what works for you. All right. So to start off with debugging your own code, we're going to talk about the highlighted lines here. So we're going to talk about traceback, browser, and R-lang and trace for tracebacks. And to do this, I'm just going to jump into an exercise. So Normally, like in a longer workshop style, I would kind of give you a little bit more of an overview and then have you work on the exercise independently. But we only have 1 hour. So I think you're going to get the most out of this if you see me work through the exercise. Now, if you want to follow along, you can do this by executing use course rstats-wtf/wtf-debugging. WTF stands for what they forgot to teach you about R, that 2-day workshop I mentioned. And we're going to enter exercise 1. Now, I already have this pulled up in RStudio. All right. So I'm going to go into my 0-1 exercise folder. Actually, I'm going to zoom in a little bit. I imagine that's a little tight. All right. Is that font size good?
Yeah, that looks pretty good here on Zoom.
All right. So, and to speed things along, I'm just going to go into the solution scripts. The other scripts are if you want to work a little bit more independently and have a few more challenges along the way. So please remember that this example was originally used in Jenny Bryan's keynote. So I did not come up with this example, and it is here for you to use. All right. So first of all, I'm going to open a source.me file. This source.me file contains a function and some data. So the data I'm creating is called fruit, and the function I am creating is called fruit average. And it's called source.me because I want to emphasize the importance of sourcing in the function for the best debugging experience. And that is as opposed to like highlighting the lines and submitting them in your browser. So for the best debugging experience, you're going to source the script file. So you would have a separate script with your functions in it, and you're going to source it in using this button right here. So I'm going to click on it, and now it's sourced in. And now you can see in my global environment, I've got my fruit data, and I've also got my fruit average function. So here's my fruit data. We have columns with 4 different types of fruit, and we have rows with attributes of those fruit, which include calories, weight, and yumminess. And if you want to get into a discussion about why this is not tidy data, you can do that in the chat. We'll save that for another day. Okay. So we sourced that source.me script in using our source button, or you can alternatively use the function source. We've already looked at our fruit data, and now we want to see a successful execution of our fruit average function. So here we're going to get the average of our fruit attributes when it matches some sort of expression. So here we're going to get the average across all of the berry fruits. So we should expect to see averages for the blackberry and the blueberry columns. I have a debugger on because I was playing with it yesterday. Hold on. All right. I'm going to go ahead and restart R. So I did session, restart R. You can also do Control Shift F10. I am going to resource in this file because it had something in there that I did not want to have in there. All right. I'm going to confirm that it works for berries. All right. So we found 2 fruits that were in the berry family, blackberry and blueberry, and we know their average calories, their average weight, and their average yumminess. Let's take a look at fruit again. Now we're going to do the same thing for peach, and let's see what happens. There's only 1 column that matches peaches, and we hit this error. Oh no, something happened somewhere. It looks like row means X must be an array of at least 2 dimensions, and we need to figure out what happened. So the first concept we're going to talk about is the location of the error. We can find the location of the error using a base R function called traceback. So the base R function kind of shows you first where it ends, the error message on which your function ended. Stop must be an array of at least 2 dimensions. and then how it got there. So it got there from row means of something called minidat, and then it got there from executing fruit average. So it's telling you the steps that it took to get to there. So we know based on this traceback that our function errored out somewhere in row means. And I want to highlight, and it says just so we can compare to what we're going to see in a minute, copy and paste the traceback results so we can compare later. One thing that's really cool here, though, is it shows you like what script that line was found in, and on top of that, the row number where that was found, which is pretty cool. So if we go over to our source me file, here we go. Row 13 was exactly where row means was executed. So it's telling you precisely where that error occurred. And I would just want to contrast this real quick. So I'm going to do session, restart R. And instead of sourcing this file in, I'm just going to highlight and submit fruit. And I'm going to highlight and submit fruit average. And now those are things in my global environment. But if I were to execute my fruit average function and then do my traceback on it, you see we have a little bit less context here than we did before. So remember before it showed like, oh, hey, we were in the 01 source me script on row number 13. And now that context is lost if I'm just highlighting and creating those objects in my console as opposed to sourcing them. So I just kind of wanted to emphasize why sourcing gives you a richer debugging experience. Happy to take any questions if there are any. All right. So I'm going to resource in that file now. And now we know that we have an error. I want to show you one more way to get a slightly different traceback. So there's an option you can use from the rlang package. So if you set options error equals rlang and trace, and now we execute our fruit average again on Peach where we expect to see that error. And now we run, as suggested here, rlang last trace. So you can either do that by clicking it or submitting this line of code. You get a slightly different visual of that traceback. And there's some additional really nice context in here. So some context that it tells you is where that function was found. So fruit average was found in our global environment. Row means is a base R function. And again, it tells you exactly where that code that you own is located that resulted in the debugger. So I'm going to not resulted in the debugger, but resulted in the bug. All right. Just to kind of emphasize the difference here in what you get between the base R and traceback and the rlang. Thank you for that, Jonathan. Okay.
There is actually a question about this, how it said base. And someone has asked, will it always tell you where the function comes from, even if you don't explicitly say like base row? Like how often will it tell you that information?
Yeah.
And how does it know?
In my experience, it will always tell you that information of which function from which package it is using. I imagine it'd be wonderful help if you're running into some sort of filter issue and you don't know which filter function you're using. It'll tell you which filter function is actually pulling in.
Classic, the classic blunder.
Yeah. And there's another question. What does the rlang and trace change exactly? It changes the default error option in your RStudio session. And then I believe, how does it know? I think it's gonna, how does it know which functions in which package? I think it's from whatever is available in that current workspace. Right, did we get all those questions?
Yep, I think we did.
All right, great questions. Keep them coming. All right, so now we know kind of like where this problem is. We have a problem with row means. Like, okay, now why do we have that problem? Now we need to know the context around why we have that problem in row means. All right, so we are going to go back and put in a browser statement in our source me script. A browser statement is a function. A browser is a function that will allow you to enter something called the interactive debugger, which is very exciting. Kind of frightening the first time, but also very exciting. So all we have to do is anywhere in our function, and just for example, I'm going to put it on the first line of our function. I'm going to insert browser. Now we are going to restart our session, restart our. Now we are going to resource in this file. Now we are going to trigger our interactive debugger. Now, one thing I want to emphasize is that once you're triggering an interactive debugger, the interactive debugger is actually triggered upon function execution. So it's not necessarily triggered only when you have an error. Like we know Peach is going to result in error, but instead of doing Peach, what if we do Barry, which we know Barry works? Like there was no error on Barry, but I still want to get in to my function and see how things are executing. So instead of executing it on an error call, let's execute it on something that we know is successful. See what happens when it's successful first, and then maybe go back through and see what happened different when it's an error. All right, now I've executed my function through average, and I've entered interactive debugger land. So there's a few things here that you see are different. One thing is you have a different prompt over here in your console. This browse bracket 1 indicates that you are in the interactive debugger. You have a little bit of a new navigation bar here that we'll get into later. Your environment on the right-hand side shows you what environment you're looking at. And now you're looking at the environment available to the fruit average function. And you can see the objects that are available in this environment. So some handy things that are like just in your browser console, like in your interactive debugger console, you're just going to treat this like a normal R console. And you're going to do every single exploratory thing that you would normally do in your R console. So maybe I want to know like everything that's available to me. So the objects I have are dat and pattern. Maybe I want to know like what's going on with that using the stir function. Okay, so now I know it's a data frame and it's got some columns and some variables. Maybe I want to look at everything and its structure. So ls.stir is really handy to see just a quick glance of like, what is my dat, what is my pattern, and everything that's in this environment. So I haven't done anything with my function yet. I'm just kind of exploring right now what I have available to me. And what I have available to me is just some data and some patterns. All right. So the interactive debugger will take some keyboard commands. One keyboard command is in for next. So you see this highlighted line is kind of where we opened up our interactive debugger. I'm going to hit in for next. And now we are going to start executing these things one row at a time. We're going to step through our function. So this highlighted line for calls has not been executed yet, but let's go ahead and execute it with n. All right, so now we have executed this calls function and we're identifying, remember if we look at that, what calls is doing is it's identifying the columns that are associated with this berry pattern. So it's saying column positions 1 and 2 are what are associated with this berry pattern, and that's what I need to take moving forward for my averages. So mini-dat here, you can see I'm going to hit in for next, is going to create this reduced data frame with only the columns that need to move forward. So that's based on columns 1 and 2, my berry, blueberry, blackberry column. So now I have my reduced data frame. I'm going to go ahead and click in for next. And now I have created this message that we found 2 fruits. And I'm going to head and click in for next. That is going to signify the end of the function. It's going to return the row means. And at the same time, because it's the end of the function, the debugger is going to exit. So it's going to look very different in 1 minute as soon as I hit in for next. So in, enter, it's going to compute those row means and conclude the execution of the function. So we just walked through the debugger on a successful execution of the function. Now we're going to walk through the debugger on something that's going to trigger an error. And we're going to see if you can spot why that error happened. So we are going to, instead of doing berry, let's do peach, which we know is not going to work. We're going to get that error. Something weird happens in row means, and we got to figure it out. All right. So now again, we can get off by orienting ourselves to what's available to this function environment. Again, we have our DAT data frame and our peach pattern is what we're looking for. We're going to do in for next again. So we're going to see what calls are we looking for. So if we're looking at our DAT, it says we're looking at the 3rd column. That looks to be correct. So peach is in the 3rd column. That's great. That's what we want moving forward. Okay. Now let's click in for next, and we're going to get our mini DAT. All right. And here we have our mini DAT. Okay. So that looks like the values for peach. Looks like a 59, a 50, and a 10. That looks okay. But does anyone kind of see right here, like what might be the problem compared to what we did with the berry execution? Yes, there we go. So it is a vector all of a sudden this time instead of a data frame. So when we did this with the berry execution and we returned 2 columns, the mini-dat returned a data frame. Now, when we're returning a single column, unfortunately, we have returned a vector instead. So again, you can take a look at this by like dir mini-dat. It's an integer vector. And when we go to do operations on this integer vector, like maybe I want to know the number of columns of mini-dat, well, that's null because it's an integer vector. It doesn't have columns. So if we click next, that's kind of why you get this found blank fruit, because it's returning that null value for the number of columns. And then now when we click row means, I'm going to just hit in for next, and we are going to just find that error in row means right away, and it's going to end the debugger process. So I'm going to hit in for next. And now we found that row means error that we already knew about, but now we kind of have that context about why that error is happening. It's happening in row means because the input is now a vector instead of a data frame. Now, something else that's pretty cool that you can do here, I'm going to do this again, is there's other keyboard shortcuts you can use when you're stepping through your debugger. So let's step through this debugger. I'm going to hit in, I'm going to hit in, I'm going to hit in, I'm going to get back to the same place, in. Now another command that we can do You ready for this? I'm going to use S. S. Instead of executing row means, it's going to allow you to step into row means. And remember, we don't own row means. Like row means is some base R function we did not write. But now, S. Here we are. Now we are in row means land. And so now, if you needed to dig into row means and see why row means was creating that error, which we already know of, you can have the lovely joy of reading this code. And yeah, so now you could still continue to hit N for next. It will still loosely know where you are. It gets a little bit, the highlighting is a little less precise when you don't own the source code. And it even gives you this warning here, like debug location is approximate because the source code is not available. Like you can open it, you can see it, you can step through it, you can highlight and run anything. Like I can copy and paste that and run it in my console and all of these things. Treat it like a normal console and keep stepping through. And then kind of around here is where we're going to hit that exact error message that you hit, that we shouldn't be going this far in it. I don't think. I did something weird. We should have hit that error message earlier, but that's okay. Well, I didn't. Yeah, I don't know. Let's do this one more time. Let's see here. So in.
When you get to that message, there's a question about why doesn't, oh, sorry, I didn't say it fast enough. Why didn't N call through an error?
Because like yeah, I'll go
Yeah,
back in there. In call didn't throw an error because it returned a null,
yeah,
not
yeah.
because it,
Yep,
like null was a valid thing that it could paste into a message and it showed up as blank.
yep,
So yeah,
yeah. It doesn't error on a vector. It just is like, the
yeah.
answer is nothing.
All right. So yeah, I did it kind of fast there, but if you just properly go through the next steps, you'll hit the same error when you step in to that row means function eventually. All right. So now normally about this time, everyone's like dying and scratching their head and be like, how do we fix this problem? So just so you can actually focus on debugging and not like trying to like over there, like create something. Does anyone know how to fix this problem? Yeah. So if you are, Andrew dropped it in the chat. If you are following along with this particular exercise, there's this secret fixed one over here. And so all you would need to do is not all, like it's pretty hard to know that you can do this, right? But in the construction of your mini-dat, you would use a drop equals false argument. And that will retain the data frame structure instead of converting that single column to a vector. So now you can stop worrying about how to fix it and you can focus more on debugging. Are there any questions about that? Okay, so I think that is what I wanted to go through for exercise 1. Let's talk.
While you're in a little bit of a pause or a transition
Mm-hmm.
point, a question came up on the Q&A that you might not have pulled up that where people are wondering like when can browser be used? Specifically, they're like, does browser work in, if you're rendering a document or if you're in a Shiny app, like what happens when you're trying to do that? So maybe before you go to the next thing, it might be good for us to say like the things that you've showed us so far, when will it work? When will it work? And when will maybe you have to use other kinds of tools?
Okay. So I think it works. These tools are going to work great if you have a standalone script of functions. These tools are going to work great if you're building your own package. These tools are going to work great if you're going to try to see why other people's packages and functions aren't quite working as expected. I use these tools a lot for iterating on my own internal packages. So when, I built something for our workflows and I'm like, I think I got it right, I think it works. And then all of a sudden I throw some new data or some new process at it and it's like, that didn't work this time. And now then I actually go into the debugger to figure out why my own function isn't working and how it needs to be updated. As far as like, what other things can I do with this? That is not my forte. So we have some special cases at the very end of the slides. So our markdown special case, I would have no idea what would happen if you tried to put a browser statement in our markdown. Probably nothing good. But some things that you can do in R Markdown, definitely use error equals true will allow you to render your document with errors. And so instead of like halting the execution, it'll keep going and showing you the error messages. Also, like knit exit is like the best thing you can do to like end a markdown document and then like iteratively work through it. So I'm like, I want to exit here. Did it work? I want to exit here. Did it work? I want to exit here. Did it work? So those are great tools for R Markdown. Piped expressions can be tricky for debugging. There's some options you might want to try there. And then I thought I didn't even want to get into it. I didn't even put a slide on Shiny. I have no, like Shiny is its own thing. Thank you. There's an article for debugging in Shiny. I'll add that as a list to these slides. Can you please?
Are you going to talk about debug and debug once?
Yes, I am.
Okay.
That's coming up.
I will save that then.
All right.
Yeah. So actually, the answer is that browser does work really well in Shiny
Oh,
apps.
really?
Yeah.
Okay.
Specifically
Nice.
browser. Yeah.
I don't do Shiny apps day to day.
Yeah.
All right. Okay, so let's get back to section 2. There were a few things that I kind of maybe pointed out that skipped over in the IDE. So we're going to talk about some things that are in the RStudio IDE, including breakpoints and your error inspectors. So I am going to restart R. Give myself a little blank slate here. I'm going to go to 02 exercise, 02 solution, and I am going to open up the source me document. The source me is essentially the same thing, just with like a slightly different structure. So instead of one fruit average function, it's still a fruit average function, but it's composed of a series of many functions, including like find, calls, reduce stat, message fruit, and compute average, in order to just to kind of illustrate what might look different in a traceback or in stepping through functions. So I'm going to go ahead and source this document. We've already seen our fruit data. We already know that it's going to work for berry. We already know that we're going to hit an error for peach. We're going to look at this traceback for peach. So remember, we have a slightly different structure here. So I created a series of sub functions or mini functions in order to do it. So you see a few more steps and you see those steps written out into your document. And now we're going to turn on our rlang and trace error option and do this again. And here we have this like context. My font is too big, but it's still showing you kind of the steps that it went through. So we looked at the global fruit average function and then also the global compute average function. And then we're still getting that error down in our base row means function. All right. And now let's open this interactive debugger. We're going to do interactive debugging differently. So instead of inserting a browser statement, I'm going to insert something called a breakpoint. So if you've ever, this is left-hand side over here is called the gutter. And maybe you've accidentally clicked on the gutter and seen this little red dot. And you're like, what does that red dot do? I don't know. It's actually a breakpoint. And it functions exactly the same as a browser statement. So now I'm going to reorient this. You can see that my fruit average function over here has this little red circle on it, which means the breakpoint has been activated for this function. And we are going to trigger our interactive debugger for Peach again. So we entered the interactive debugger by using the red circle breakpoint instead of using a browser statement. And everything functions the exact same way now. So we can still step through in all this. Now, instead of typing in for next, I'll just highlight now that you have this bar on your console that will do the same thing for you. So we can type in for next here or click on next. And now we're on our highlighted line message fruit. I'm going to click on next. And this little arrow into the brackets, that's your S. So that's your step into. So now we can step into compute average on Minidat. And we can keep stepping into that if we want to step into row means and keep stepping into it. So there we are. Now we have got to the exact place of where our problem is, and I'm just going to execute this, and we've hit our error again. One thing I also forgot to mention when we were talking about the browser statement is that you can put the browser statement anywhere in your function body. So it doesn't have to be on the first line. It can be, you could insert your browser statement here, for example. And what that would do is it would execute everything up until that point. Instead of illustrating it with the browser statement, I'm going to illustrate it with a breakpoint. Here you see this red circle, which is indicating to me that I need to resource in this file. So I'm going to do Control-Shift F10 to restart R just to be safe, get everything out of my global environment. I'm going to resource in this file. Now that red circle has shifted to a solid red circle, indicating that breakpoint is active. Now I'm going to execute my function again. Again, it can be on an error or it can be on a successful execution. The debugger is helpful actually in both contexts. So now when I have executed this, you see I have more things available to me in my function environment because that breakpoint was set later. So it already executed calls and Minidat and message fruit. So it can allow you to skip some steps if you know you want to dig into what's happening later in the function. All right, and that was successful execution. To take off your debugger, you're just going to left click in your gutter again, and your breakpoint, and then your breakpoint has been unset. Pause for questions. One thing that was mysterious to me before is why this like bar would sometimes pop up. I'm going to, in my RStudio session. So just to make sure you're aware of it, you also have this debug menu, and there's on error. And the default for most people is probably on error message only. And that's what we've been experiencing so far. I'm going to source in this file. There's no browser on this file. There's no breakpoint on this file. There's no debugging set on this file. I'm just going to source it in. And I am going to just remember that on error is message only. And let's just trigger this. Yes, Peach is an error. So now we have our message only from our debug menu. You can change that debug menu to error inspector. Sometimes I think I've been working and I didn't really know that this was activated or why it popped up. An error inspector is what gives you this gray bar in your console that it gives you the two options. The two options it gives you are show traceback, which we've already discussed. tells you the steps that led up to that error. And it's also going to allow you to rerun with debug, which is going to open the interactive debugger for you. It might be surprising to you, or it might not be, where it opens your interactive debugger. So I'm going to go ahead and click on rerun with debug. And can you tell me where it opened up? So yeah, it opened up right here. We're still in our interactive debugger land, but it jumped straight into row means. And if this is the first time you're trying to figure out why we have this error, it might be disorienting, because you might be like, I didn't write this code. Where did this code come from? And how did I get here? And why am I here, right? So I think it's a useful option, maybe when you kind of know your way around your functions and exactly what's calling what where. But maybe if you're just still in that exploratory phase and understanding phase, it might be more helpful to step through iteratively first. And then the last, I think I did on error. So error inspector gave you that gray bar with the traceback or debugger options. And then there's the break in code option here that I have now activated. And break in code just says, anytime I got an error, take me there. So break in code is opening the debugger on error at the exact location of that error. I'm going to change it back to message only. All right. So that's a little bit of what the IDE has for you. I'm going to restart R again. And now we have 10 minutes left, and Andrew, you can't leave without debug and debug once. We got to do it, right? So let's go over here. We talked about IDE features. I think I skipped over something. All right. We're going to talk about debugging their code. Now, this might be code that you do not own. Like, you have not written these functions. You are not sourcing anything in. You did not write this package. How are we going to navigate code that you don't own? And you've already kind of seen that the tools are there, right? You don't own row means, and you still got into it. But you did get into it by actually manipulating a function using the browser statement or by using the breakpoint. And if you don't own the code, then you can't use a browser statement. You can't insert a browser statement into that function, or you can't set the breakpoint. So we're going to talk about debugging their code using the debug or the debug once functions. And to do that, we're going to go into exercise 3. Please save this chat for me. I want all of these notes. Okay. So exercise 3, debugging solution. Clear the console. I think I already restarted R. All right. Now, there is no source me for exercise 3 because there's this little mini package that I've created called WTF debug. I'm going to attach the package. Notice there's nothing in my global environment. You don't see fruit there because fruit is now in the WTF debug package. And this is simulating the idea of like someone else owns this package. I've installed this package and something weird is happening and I need to figure it out. So here's the fruit data that's in the WTF debug package. We're going to confirm that the fruit average works for berries, and we're going to get that error again for peach. But now, and maybe we'll do our traceback. Our traceback might look a little bit different, especially with the rlang option. So now, because these functions don't live in our global environment, it's specifying that, hey, I found fruit average in WTF debug. I found compute average in WTF debug. And then we found that problem in base row means. Now I want to get into fruit average, and I want to see what is happening. So there's this function you can use called debug once. What debug once does is it's the exact same as inserting a browser statement into the first line of the function. It's also creating that browser statement, or allowing you to enter the interactive debugger a single time. So one time only. That's why it's called debug once. All right. So nothing's happened, right? I just did debug once fruit average. Nothing is going to happen until you execute your function. So now I'm going to execute the function. Again, it doesn't matter if this execution is on a berry or a peach. It doesn't matter if it's going to render result in an error or not. So I'll just do on berry on the successful execution. And now we're getting that same message that we saw before. Debug location is approximate because the source is not available, because that source lives in that WTF debug package, but it's still allowing you to pull it up. You can still step through this function next. You can still like step into things using the step into, see what happens when you create your DAT, go through your next, and work through the debugger just like you would in the other circumstance. It's just that the method, the mechanism by which you got there was debug once instead of inserting a browser statement, or instead of using the breakpoint. So, and again, that's going to have that successful execution. The alternative to that, so now if I execute, let's see here, fruit average again, it's not going to trigger the interactive debugger because I only debugged it one time. So I'm going to execute fruit average, and now I found 2 fruits, and it's like executing as normal, no longer triggering the interactive debugger. Another way you can do that is, instead of debug once, you can debug fruit average. Now this keeps that interactive debugger on until you choose to turn it off. So I am going to do this for peach. I'm going to go next, step through, and I found my error. And then I'm going to execute my function again, and I'm in my interactive debugger again. So I'm going to go next, step through, found my error. And then I'm going to execute my function again, and I'm in my interactive debugger again. So if you ever want to turn that off, you have to undebug fruit average. And then that will allow you to resume execution of the function without entering the interactive debugger each time. So I think when you're, there's a lot in here that we're not going to get to. We've talked about different things you can do with tracebacks, right? You can use the traceback function or change your options for that rlang experience. And we talked about different ways you can enter the interactive debugger using IDE tools, using the browser statement, using the debugger, the debug once statement, using options as well. Kind of the sweet spot for me are these tools that allow you to work both on your code and someone else's code. And then you don't have to like remember like what tool to use when or whatever. So I personally use debug once a lot. And if I don't use debug once, if I'm working in my own package, I probably use the breakpoint. But they're all tools that allow you to enter the interactive debugger. So you choose, like, just try them all, like, and see what feels right and what feels comfortable for you. And then also, like, it's like a fun learning experience to learn from your bugs. You're always going to like dive a little deeper and get to know a little bit more about your code and the code that it uses. So yeah, I'll pause there and we have a few minutes for questions.
Awesome. That is so great, Shannon. Yeah. So, Libby said she likes debug once because browser is hard to spell. No, I like debug once because like I find myself, I'll do like debug once over and over again
Yes,
rather than
me too.
debug undebug, because for some reason, like I'm like, oh my gosh, when I have turned debug on, I forget, and it's so surprising. It's so surprising to me if I've turned debug on and then I forget or get yeah. Yes, and Andrew just said debug once is so great because if you're in something that's going to be called a bunch of times, it only does it one time. So you don't end up in that like loop forever kind of situation, which is
Yeah.
also really great. Also really great. I um okay, great. Yes, I think debug once is like the hero of debugging for me.
My sweet spot. Yeah.
Yeah, that's the one. And it is amazing how there are so many tools, but you only have to learn a little bit of them to really
Hmm.
level up your ability um to get unstuck and to like make headway, which is
Yeah.
really great and fun.
Agreed.
Nice. So I think we answered most of the questions as we went along. So if anybody has an additional question um, that they want to drop in here, I guess one as folks are thinking about what to write. Do you, if you think about the time you spend writing analysis code and the time you spend writing package code, when when do you find yourself reaching for debugging more?
Package code.
I think that aligns with my experience too. I think that's what I find as well. And do
But like
you, yeah, go ahead.
often it's, you know, we write functions to streamline some of those standard analyses too, right? So yeah, they go hand in hand.
Yeah, that's for sure. That's for sure. Nice. Nice. Well, we're up to the hour. And Shannon, thank you so much for this great presentation, for sharing all this with us. I will drop a link to our next meeting, which will be in June here. So we have Tom Mock is going to come, is going to talk about using Copilot, GitHub Copilot in
Right.
our studio and whatnot. So it should be a good meeting. You can get exposed to that and see how that tool works. So thank you all so much for coming. Thank you once again to Shannon, and